Good morning, everybody. Hope everyone's having a nice day. Yes, right. So, no streaming yesterday. Didn't get any work done. Was going to do some work, but it didn't happen. What are you going to do, eh? All right. So where did we get to the other day? We were talking about job setup. We tried to do some panelization, but then we realized that we needed some jobs and things like that first. Morning, Dartman. Hi, everyone. In the chat. There we go. Hi, everybody. Yeah, so we started doing that, but then we quickly realised that there was a lot more to it, so we couldn't do panelization straight away. It's just the way it goes sometimes, really, isn't it? And where we got to was writing this test. Yeah. So we decided that we were going to create a new CLI tool called Job Builder. Obviously, we're going to have a GUI for all this at some point, but to get all the concepts and all this kind of stuff sorted out, and some of the pieces of the puzzle that a GUI, as well as any other kind of form of user interface, is going to need to get some of these pieces of this puzzle, we're going to start with a CLI tool. So what we said was, we want this horrible worst case scenario. And I was thinking about this a little bit this morning. Often the way you do with test-driven developers, you start with the most simple test first. And we sort of did that a little bit in that, we created a tool and we could, give it no arguments and it runs, and that forced us to build a CLI tool. But then we're on to the next most simple thing it should be. But this isn't the next most simplest thing. But the thing is, though, that this test is the test that drives all of the command line arguments that you need to have. So we could start with, say, defining a single panel, then adding support for multiple panels, then adding support for design variants, and then adding support for multiple design variants. But what is basically going to happen if you start using clap and things like this is you basically just have to come back to those things and just sort of like add list to it. So I don't think there's too much value in creating this simplest one first yet. Like, I say yet, perhaps if ever. Perhaps the simple test should be done sort of more at the unit test level rather than at the functional test level. Certainly for the command line arguments, anyway. I think. I mean, it's possible that we could even write unit tests for the clap arguments, but I think basically at that point you're just sort of testing the library, really, aren't you? So we're going to crack on with this and we'll see where we get to. So let's see what we've got. We've got a failing test. Perfect. Yeah, let me bring up logsec again and just remind everybody what we were doing, or what we were talking about on the last stream. This is jobs, and we basically just wrote down a bunch of thoughts on here. Going on to this logsec stuff, we could start adding in some sort of tags and things like this on here at this point as well. So for instance, I could add some tags on here. So like assembly, variant, and job, and panel, and panelization, and things like this. Feeder perhaps, and scenarios, and use cases, and designs. I don't know the designs. And then we basically got some tags, and then we can refer back to these and other things, and then that allows us to have a view of linking all these things together. All right, so yeah. So yeah, right, back to the jobs. So yeah, all right then. So yeah, so we've got this, and it doesn't like the panel. So we basically need to add the build. We've got to start adding some build command and some stuff like this. So we'll have a crack at doing that. All right, then here we go. Where's the code? Where's the production code? It's in bins or something, wasn't it? Job builder. Yeah, righto. Yeah, so we're going to need some options. So we said we're going to flatten the sub command. Let's have a refer back to the other one that we did. Yeah, here we go. So we used the command build, and the build had various different things that we want. So substitutions is one of the arguments that we used in the other tool, and this has a vector of strings, and this is essentially what we want for a few of the things that we're doing today. So panel needs multiple things, and it's possible that we have to change this a little bit, but we'll deal with that in a minute. Okay. So let's start with this. Now, panel. Okay. All right. Let's paste this in. Not here. I think it was like this, wasn't it? In the enum variant, yes. Right, but not substitutions. Let's say panel. Is it? Like in there, it's panel, even though it's panels. Let me look at that. Because I want the things in here to have the plural on this on the name of it, because it's a vector, right? So it probably makes sense to say panels like this, and this design variant should probably be design variants, and these should be like done the same way. I think something like that. Let's have a look at the clap documentation to see whether we can also have some way of specifying this, like, you know, you need 2 arguments per one of these, or, you know, something like that. Or 1 argument per panel or something. Let's see what we can do, see if we can make this nicer. Let's have a look at Rust clap examples. Examples. Here we go. Yes. All right. Well. What are the names of all these things? It's kind of difficult to search for these things if you don't know what the names of the concepts are. There we are. Group. This group thing all about? Yes. Sometimes I really wonder whether we should be using the derive thing or not, to be honest. Just looking at this for a moment. Hmm. Just looking at example to see if there's any stuff, information we can glean from it that might be useful. Um, yeah. Hmm. Can you have multiple commands? Like, I sort of want multiple arguments for like a design variant, and then these two things are the multiple arguments, and then I want sort of pairs of them, right? Um, let's see if you can do clap, rust, clap, tuple, tuple, yeah, fixed size array, yeah, yeah, something like that. It's something like that. It's similar. Yeah, no, it's there. Hmm. Arg group. I don't really think it's an arg group. No. Aliases, visible, it's sort of to do with like the number of arguments and so on like this. Value parser. What on earth does get matches from? Oh, I see. This is running this, right? Hmm. Yeah, this is a bit of a funky one. I'm not really finding sort of what I'm looking for really yet. Not very exciting, this stuff. Um. Well, I guess we'll just try and proceed, and then maybe we can come back to it. If we find a better way of dealing with it. Yeah. So we'll just do some sub processing sort of later instead of trying to define some funny type that's can magically be populated from semicolon separated things. I don't know. Maybe we could do it. Maybe we could do it. Maybe we could do a value parser and then do it. Let's just use strings for now. It's an optimization for later. All right. So panels check. Panels check. How many panels can we have? There needs to be 0 or more, which is fine. And I guess we can go comma like this here, which is what we said. And we need an equals, so we're going to have equals like this. And we'll do the same format everywhere. Because we did this in our other tool, so it should at least be consistent, right? It might not be the clearest way of writing this thing, but if we change it, we'll change it for everything in one go, and we'll change the other test as well. Panel mappings, design mappings. Why have I got this one twice? Oh no, that's right, yes. Because they're sort of indexed based. That's right. Okay, fine. So we've got those. So we can go back and go panels. Fine. Fine. And then the next thing we want was design variant. Yeah. Something like that. And you don't need any of those. And then panel mappings. Yeah, same kind of thing. Probably should use a lowercase v here. And this is going to be something like panel range and then the design variant. Like that. And then I suppose we have design mapping. Yeah. And this is going to be design variant, blah, 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 blah. This is what we want to say. We want one for each unique PCB. And then the panel should be one for each panel. And then design variants and panel mappings. I suppose, yeah, you can have one panel mapping which says panel 1, range 1 to 6 is design variant 1, and that would be that. Yeah, design mapping. But because a panel can have multiple designs on it, then you can specify numbers, but for the individual designs, there's no sort of like numbering within a design. It's a single thing by itself. So then here there needs to be one for each, yeah, unique PCB in the job. I suppose it's not really unique. Yeah. Something like this. Okay. Right, what happens now? I mean, it compiles. That's good. Well, look, it didn't crash. Yeah. Yeah. Right. Right. What's next? Let's have a look. Let's have a thinkamy. So we can pass arguments. Oops, lady, that's the wrong button. It's definitely the wrong button. What did I press there? Oh, right, okay, we'll try that again. Over here, there we go. So great. So we've got a command line tool which can accept some arguments. Brilliant. Now we want to probably do something with the arguments, perhaps. I don't know. So how about every time we come across something that says panel, we well, let's make it print out in the trace log what the job is supposed to contain. Okay, fine. So the way we do that in our other test is to look at the trace log file and assert there's some stuff in it. So the way we did that was this kind of thing. We look for a specific message. So we'll just steal a bit of this. And then we'll do something like this here. And then change these as is appropriate. So let's say job definition. I mean, we said, I don't know. Yeah, job definition, job setup, job setup. It's not really job setup. You sort of set up for the job. I don't know whether the name for the stream was correct. Really, it was my first thought, and normally with the first thought on namings, it's wrong. Job definition. Let's go with job definition. So panels. So what we said was we want panel 1 and panel 2. But with white space. Okay. Let's make that happen. Fine. Okay. So somewhere down here, we have to do some stuff. One of the things that we need to do is make sure the trace logging is set up correctly. Now, in our other tool, we have this configure tracing thing here. And I don't really want to copy and paste this. I feel I want to extract that somewhere. Let's go with a new package called CLI, but only. Oh, it's. I forget how you do it. It was like this. I was on the right track. Everything was fine. So we've got a CLI mod if we've got a CLI feature. And in this CLI mod, we could create a tracing thing. Right. And then the idea is then to take this bit of code and move it to this new file that we just created. So it's CLI tracing. Let's see if it works. Conflicts detected. Okay. It didn't show me what the conflicts were. Oh, we've got these opts thing. So this is what the problem is. We've got this variant builder opt, but it doesn't really care about that. It just sort of cares about this trace thing, which should be an optional path. So let's just say path option, something like that, probably. And let's go back to where it was called from. It was here. And then if we take opt dot trace or something, because that should give us this, which is option path buff, right? Let's just make sure that works. It does indeed still work. That's good. But there were some warnings there, weren't there? What's this? Doesn't need this anymore. Fine. Doesn't need these two. Good. Okay. So now we can reuse that in our other thing. Hopefully. Yeah. Great. So we've got a call to configure tracing here. So if we grab that job builder and plop that in there, import that. But now we actually use the opts, so we can take this off. And that should be okay, right? Yeah, so it doesn't print out job definition. So how about we say, I suppose we've got to check to see what the command is. Match opt dot command. Was it? Should probably be Commander. Or it should be, actually. Let's fix that in the other one as well. Oh dear. That's the wrong key. So the idea was, oh yeah, fine. Oops, daisy. I keep losing my spot. Come on, where are you? There you are. And if we say it was the build, then we do some stuff inside it, right? And it gives us these things. And then we need to run a bit of code with it. Great. Now, with the other tool, and we probably need to refactor a little bit. With the other tool, we've got some of the logic of doing what needed to be done mixed in with what it did. But there was only a little bit where it was mixed in. Let me show you where it is. In the variant builder, we've got this build assembly variant, right? And it does indeed build a variant. But it loads up a bunch of things first, and then it sort of builds a variant, and at any point it might fail. And it does some trace logging. And then it writes a CSV. Some of this stuff needs to be pulled out of this method and put into a bit of code which lives in the library, not in the CLI tool itself. Was what I was thinking the other day. But I'm not going to refactor this just yet, but I don't want to follow the same pattern that we did here. So we'll try and create the new pattern in the new tool and put things in a more sane place. Yeah. So we'll just be mindful of this as we do it. So we'll say, I don't know. What are we doing? What are we doing? We're sort of validating arguments, like define job. Do we? I mean, it says job definition. Let's say let. Well, I don't know. Okay, let's go build job definition. Right, and we'll pass it the panels, and we'll pass it the design variants, and we'll pass it panel mappings. And these are all arguments at this point, don't forget. And we'll pass it the design mappings. Okay, and we'll put the question mark semicolon on the end. And we've got this function which does this now. Fine, right? Now, so yeah. Oh, I've got a typo. Right. The problem is we're sort of still in CLI land here. And if you remember from our test, which was this one. We've got sort of like this semicolon separated, I'll say, nonsense. And it feels like I can have one method which does process job definition args. Yeah, okay, let's do that. Let's do that. Because I don't want the build job definition to take these semicolon separated strings. I want it to take the right things, which is not a vector of strings. It's going to be like, you know, a vector of a panel, or, you know, this kind of thing, right? And this one's going to be, you know, design variant or something like that, right? And this one's going to be panel mapping. And this one's going to be design mapping, right? So somehow we need to go from this semicolon separated list of stuff, validate all the input on it, and then build some objects as a result of that. Now, yeah, I think we might be doing custom argument parsing stuff in clap at this point. I don't know. Let's see what happens if we just do it the crap way and then go from there. Okay, so what we're trying to do what is this going to be? Job definition? I don't know. And then we're going to say, yeah. So we want to do that. And perhaps something like result dot panels, result dot design variant. Result dot panel mapping. It's just argument passing at this point, but you know, getting this structure right is important. Something like that, right? And then once we've got that, we've got job definition, which might fail. And then we can say dump job definition, and we pass it the job definition, right? And then in our, and we can have a function dump job definition. And then here we can finally go info, and then whatever we said we wanted in our test, which was this. Something like that. And we can also say that we want to print out this. We can also say let. No, I suppose we can go. Yeah, let panels message is something like format panels with a thing. And this will be, I don't know, panel, well, job definition dot panels dot map panel dot name dot join with a comma or something, perhaps. You know, something like that. How many brackets have I got? Have I got enough brackets? Yeah. Something like that. Right, and then we print out this message. Something like that. Oh, that's better. Okay, so that's sort of the state of things. So this build job definition shouldn't live in the CLI tool because it's nothing to do with like CLI related topics, right? Process job definition args should live in the CLI land. And dumping a job definition out could be either, really, to be honest. We should probably put it next to this. Okay, so we need a little function for this. Which is going to take panels. Oh dear. Design variants, panel mappings, and design mappings. And it's going to give us a job definition arg result or something, args result, something like that. And this is going to be a struct which contains these things. Let's name these things first. So this is going to be panels. Or maybe just pass the entire args thing across, but I think the args is more of like a command line tool thing. Bit of a faff. But there we go. So now we've got the list of stuff that we're going to pass over. So we can put that in here and then take the references off because we want actual things in here. Whether they're boxed or not, I don't know at this point, but we'll work that out. So now we can finally define structs for like this, and then we'll move all these into the right place in a minute, but we'll just put them in line here for now. I suppose I could just do like this. And we'll work out what goes in them in a minute. Right. So now we need this job definition thing. And this is going to contain probably similar things. And it's probably going to point to the things that we passed in. But I don't know. I don't really know. But I know it needs the panels. So if we define the panels as a list of panels, I don't know, maybe we move them to it or something. I don't know. I don't know yet. But it needs the panels. And a panel needs to have a name. Which is going to be a string. And whether it's called like panel 1 or, whatever, our arguments in our test was like this. So this should probably be the name that gets printed out, right? Yeah. Right, let's see what happens now. Right. So this needs to be an any how result of this, I think. And then this one, hold on. This one shouldn't be that. It shouldn't be an anyhow one. I think this should just be a result of whatever, and then sort of job definition error, probably. Of which there can be some things. Oh, you derive it and then you go error and then, yeah. And we'll just put unknown here for now. Right. Placeholder error. It's fine. Well, I'm probably doing this wrong. Oh yeah, that's right. Unknown error. Quite a lot of boilerplate stuff you have to write first, isn't there? No field design variant. Oh yeah, because it's plural. Fine. No method name map. Oh yeah, we need an iterator. No method join. Probably need to collect them and then join them. Return a reference to it, might be able to. Yeah. Whatever, let's just clone it for now. Oh, it still needs it. Let's assign this to something. Let panel names is going to be this. And let's just undo this. And got a reference to a panel. Which is already a reference. I mean, let's just say it's going to be a vector of string references. Can we do this? Yeah. Item changed to string. Oh, supposed to be as stir. There we go. Okay, getting there. Lots of unused variables. What happens? Not yet implemented. Great. So we're probably failing on this one. Yep. So now we can go from these semicolon separated thingamy jigamies to whatever. And now, I know we could use clap to do some of the processing for us, but let's write the basic steps of what we need to do in order to get these objects out of the strings into these sort of like nicely defined objects. And then what we'll do, we'll try and fit that code into clap. Because there's other things that we're going to need to do in this process job definition args where there's like the case of like a mismatched amount of things in there. Or whether the panel is defined as having 10 units on it. Say, and the range has got a number that's more than the maximum amount of units. You know, there's a bunch of other kind of errors that could happen with all this that we're going to need to deal with at some point. And this is probably the place to deal with all that stuff. Probably the place. I'm not entirely sure. Anyway, so what we need to do, what we said, is that we need to somehow build panels from this comma-separated list. So when we're here, we should have a bunch of panels. So let's try and return the result to start with. And we're going to say OK with one of these with panels, right? Everything's fine. But we need all the other things as well. Okay, I guess these can be empty to start with. That's fine. But we don't have panels, so we need panels. Right? Now, we've got a name of a panel. And right now we can just use that to create a panel instance. But probably what's going to happen is that we'll take the name of this panel and then we'll look it up somehow, because along with that panel, there's going to be a bunch of other information associated with it. So that when you're when you're creating a new job, you don't have to re-specify the entire details of the panel again. You just say, this is a panel, it's got these designs in it, this is where they are, here are the fiducials, and so on. But right now we don't have the definition of a panel and anything else other than the name, and we don't have anywhere to store it yet, but we'll add that later. So we'll just go let's say panel arg like this. So that we can use the name of these things as they are in the job definition. So what we're going to do is simply map each argument let's just say name here, each argument to a panel with a name in it, and then collects them all up again at the end. Oh yeah. Something like this. Right. So now we're probably onto our next one here. Build job definition. Let's see if we can write some of this. So now we should have a vector of panels in here, and we can create one of these. So let's just say OK, and then one of these things with the things in it that we need. Yeah. Why is it moaning? Why is it moaning? Mismatched types. Oh, well, I mean, it's a vector of panels. Well, job definition has got one of this, but this is one of these. Let's just clone it for now. Cloning the vector, not the panels itself. Is that right? Should we be taking these here? Should we be moving them? Let's just assume that we're going to move them right now, because I don't really want to deal with cloning vectors. Let's just go with that and see what happens. Can we do this? Does it let us? It might do. It's just going to do a partial move on each one of these things, but it's fine. We don't need to reuse this result thing afterwards, so it's fine. So yes, so now what happens? Does it run? Not yet. Well, yes, that's because I was silly. Oh my god, the test passes. Brilliant. So we've got some of the structure, but the things are all in the wrong place right now. And obviously we haven't dealt with all the other arguments. Let's try and deal with some of the other arguments before we start moving things around. A design variant. What is that? A design variant is the name of a design and the name of a variant for that design. So let's say design name probably. I was thinking about putting the design here and the variant here, but I'm not sure whether that's really what we want. So we'll just go with the names to start with. Right. So this is sort of going to be similar in that instead of creating panels, we create design variants. And this needs to be a vector of design variants, and we take that from the design variants arg. But when we map it, we have to create something else like this. And then this is where we need to be a bit more funky. Like, where do we get this from, right? Where do we get this from? Oops. That one. I'm just going to be consistent here for a moment. Okay. So this arg that we've got, let's just say arg here. And let's rename to this one arg as well. and then I think it's clearer. So what we've got to do, we've got to split the arg into two parts before we can return this. So let's do that. So we can say let design name variant name is the arg split on a semicolon or something. And we get the first two. And then we can do that, I suppose. Split. How do you do split? Oh, you have to collect still. Then what happens? Then what do you have to do? Let's say that split stuff is this. I don't know what this is going to be yet. Let's see. Type annotations needed. Well, it is going to be a vector of string. I mean, what does split normally do? Does it give us a... We don't really need a string. You know. Two string? Is there a two string implementation? Oh, well, yeah. Something like that? No. Why does it... oh, I see. This expression has type of strings. Right. Can you not... Can you not do a destructuring argument from a vector into... Maybe we should do it like that. Oh, no, 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 no. Not like that. Split args, maybe? Oops. Oh, no. What happened? Something like that? Yeah. Should we just, not do the string thing like this? I just want to sort of see what happens if you do this. What does this give you? So arg.split gives you string references anyway, does it? Yeah, it gives you a... Yeah, it always gives you string reference. It's fine. I was right the first time. It's fine. Fine. Everything's fine. Probably still passes. I suppose probably we should have updated the test to say print out some more stuff. Let's go back to the test and do that. So what did we just do? We're trying to build the design variants right now. And the design variants were these. Maybe? Like that? Perhaps? Seems reasonable. So now we can print out that. Something like design variant. Yeah, something like this. So now we need this on here. Which is fine. And that means we're going to need to have the extra argument on here. Now. But we don't have a panel here. We have a design variant here. And we're supposed to be taking the, yeah, we've got to format us. We've got to create a string. We're going to go format. Like this, I suppose, isn't it? And then return that. There's not really a lot of value in this. Let's just do a... Let's do this, look. It's going to be a bit better. The tricky bit is getting the names out of it, not the joining bit. The value of type vector cannot be built from this. Yeah, I suppose we can have string here because format is going to give us string back. Whereas this can just reference it here. Oh, it works. Okay. So we've got that. And then we've got the panel mappings thing. Well, it's not very exciting, this, is it? It's just very boilerplatey. Not very exciting. Righto. Moving on. Yeah, so we're just gonna, continue with this. Whatever. And we're gonna say panel mappings. Hold on, it's very dry. This is panel 1. Yeah, this stuff really, isn't it? Yeah. Should we let's print them on separate lines. Oh, what happened there? Oh, what is going on here? Oh dear. There we go. I put my quote in the wrong place. Let's say a separate line. Maybe we should have put these on separate lines as well. Yeah. How'd you get it to magically do it? No. Maybe there's an easy way, I don't know. Oh dear. Okay, let's make it do that. Should we do the same for panels as well? Just like be consistent, I suppose. Yeah, go on then. Okay, we'll do that. It's like that then, isn't it? Oops, daisy. Let's see what happens. It should give us a... It should complain about this. Yep. Good. Yep. Yep. Okay. Okay. Right, so we're trying to print out all this stuff. Panel mappings. I don't want to put the semicolons in this. I don't really know what I want, but I know I don't want semicolons. Do we print trees? Are we just overcomplicating things for no real reason right now? Would a tree be better? A tree would be better, wouldn't it? A tree would be better. Yeah. Let's do a tree. Come on. We know how to do a tree. Let's build a tree. Trees are good. Let's say panel mapping tree. Goodbye. Oops, daisy. Yeah, we know how to do it, don't we? Everything's fine and dandy. Paste. Delete. End of line. Much backspacing. No. Okay, so it sort of needs to be something like this. Yes. Like this, isn't it? You know? Right? And then we'll come back in a moment and make it suck less. Yeah. Okay, so we need to sort of figure out that there is only one panel or two panels and that they're different panels. I mean, do we? Yeah. I can see where this is going. Probably what we actually want to print out instead of what I'm doing now is like the giant list of components that's supposed to be on each one in the order that they're supposed to be on in this with the details of what it is. I guess we'll flesh this out. Let's job definition, panels, design variant. Do we care about the design variants here? Do we really? I don't think we do. I need a fan on, that's what I need. I don't think we care about this. Now that I sort of think about this tree stuff, this is sort of where we want to go with this, isn't it? We're trying to get out a list of placements to put in these sort of jobs and sub jobs and all this kind of thing. We haven't defined any jobs with this, so really, I suppose we want to print out like trying to come up with a list of ordered list of placements to do, really, aren't we? But nonetheless, we still want some of the details. Okay, let's say expected tree. How about expected job tree? Yeah, let's do that. I want to print out the details of the panels and the design variants, right? And there's going to be more details of this. But this panel mappings thing and the design mappings, I don't think we care about those that much. We don't care about just printing it back out again. What we care about is stuff that's going to happen. Let's say job tree. And we'll build a job tree. Right. I need the characters that come from the other test. So, we've got our tree thing like this. So we need these little characters. But it doesn't really start with a panel. It starts with a panel like this, I suppose. Right? Yeah. This sort of makes a bit of sense to me, I think. The wrong character, one of these maybe. Plop. Something like this, perhaps. No. What's going on here? Oh, I'm missing a space. Okay, and then we need some of this stuff down here. And then it's going to sort of be the same for this, right? Yeah. But this one hasn't got any of this stuff underneath it. Yeah. There's a few different ways we could print out this tree, really. We could print out sort of like all of the components sort of like in a list at the end, all of the placements in a list at the end, and refer back to their sort of initial thing, or we could just print them out in this tree. I feel like it might be a bit clearer if we print them out in this tree. I want to print the tree first, and then I'm going to add an expectation for a component to appear underneath each one of these little nodes. But yeah, then this doesn't make sense then, does it? How about then, instead of doing that, we go let me think about what we actually need to do here. What we're trying to get out of this is a list of placements in order for the machine to start placing. Once the machine starts placing it, you need to be able to stop this or pause this and then carry on from where it was, right? So each one of these sort of placements needs its own sort of like reference number, and it needs to be in an ordered list which you may insert things into or remove from. Let's do this. Let's say the first one, yeah, I think if we do this, it'll focus us onto sort of like where we actually want to go with this. Are we going to say R1? And that's all I'm going to write right now. And then at some point there'll be like an X coordinate and a Y coordinate and all this kind of stuff and a rotation here, right? Yeah. Now, the first panel has got 6 things on it, though. Right, so clearly this needs to be repeated 6 times. Right. Yes, this is definitely clearer and sort of focusing on my mind on what it is that I actually need to be writing here. Yes. Okay. Okay. Now we're with it. Now we're clearer. Right. That's what needs to happen. Yes, yes, yes. Okay, so we've got panel 1. Right, and then we need all this again. But sort of down here. Now, I was going to come along and just delete those other bits on the left-hand side, but then I remembered that we're also placing, not only are we in this job, not only are we placing 2 panels, because we said so, 2 panels, we're also placing you need to do this. Hold on a second. Wait. Yeah, we're missing. We've got some stuff wrong here. So we said we're supposed to be placing a bunch of separate PCBs, 6 separate PCBs, but the panels obviously can't have the same design names. Well, I suppose they could actually. Okay, listen. I was going to say that the panels can't have the same design names as separate PCBs, but they could if you get a panel and you take one of the individual things out and then just put it on the bed of the PC of the pick and place machine. So it could, but for this purpose, we're not going to do that. So I suppose what we need to do is say that the design 1, variant 1, design 1, variant 2, design 1, variant 2 are the things that are in the panels, right? So that needs to be like this. Yeah, right, like that. And then these are the ones. Okay. Do we need to specify them? So you need to specify the design variants for the panels, because otherwise you don't know. You just know that you've got a panel and it's got design on it, but you don't know which variant that you're trying to build. But when you're just placing random PCBs, you've got design mappings, which should probably be something like design 2 variant 1. Right? Like that. Okay. Hopefully that's clearer to everybody else. So now we need to just, have our tree list those as well. So it's going to be something similar to this, but not exactly like this. So we'll try putting it here. So we're going to say, oh, these are all design 1 variant. Yeah, these are 3. 1 variant 2. That makes more sense. Sorry, 1. And then let's fix that here. 3 variant. No, wrong number. 1 variant 3. 1, 2, and 1 and 1. Right, good. And then we're going to say we want design to variant 1. And there's no index on these things or anything like that at all. And we're just going to have a list of components for this thing. And it's going to have, just to differentiate it, it's just going to have C1 instead. Oops. And then 2. And 3. Something like that, I think is what we want to actually try and build. Right. So we're placing 2 panels with 6 design variants on each. And we're placing 6 separate PCBs in this job. And they all use the same parts, and you reflow them all at the same time, and everything's fine, and it's not a totally unimaginable scenario. Honest. Yeah. So eventually, this is going to have a location on the bed of the machine. This will have a location on the bed of the machine, and so will each of these. Right? And then once you know where the board is on the bed of the machine, then you'll be able to update the coordinates relating to the panel, the orientation of the panel accordingly. Of the design accordingly. Yeah. This all seems plausible. See, if you have a machine that has a conveyor belt that only takes 1 PCB, then a lot of this stuff is just like completely and utterly moot, because you only have one thing in the machine at a time. Well, I guess you have only 1 PCB, but I suppose you could still have 1 PCB with multiple different designs on the panel. Yeah. Anyway, right. That's what we're going to do. Yeah, that's definitely clearer in my head now. Oh, this is supposed to be panel 2 though. There we go. Job tree. So you don't have a job tree. And the whole point of this is to create a little job tree, which is, we get a job definition and we put a tree out from it, right? So I'm just thinking about how to structure all this data in there. Are we going to do a tree? Like, actual tree? Do we want that? Or do we just want sort of structures and stuff? I don't necessarily think we want a tree, but we might. I don't think we want a tree because it's much harder to sort of like iterate and navigate over a tree. The later things that we're going to need to do. But I might be thinking ahead of myself there. I don't know. Okay. So this is what we want. We want a job tree. Not that. Okay, so we want a job tree. Info. This is what we want. I can't remember. So what we did in the other tool to to print out a tree. We had some code that printed out a tree. So let's refer back to that. Our variant builder. We build a mapping tree, which is a tree of string, and it's got a print on it. So fine. So we'll say let job tree is a tree of type string. And we say build job tree. Sure. And then we printed it, we did that. I suppose the root node can be. Go back to a test. Yeah, we need this root node. Let's say job tree here. And let's ditch job tree from here. And we ditch job tree from here. There we go. Fine. So we know we need a function which, I don't know, takes the job definition and does something with it in order to build a tree. Sure. Why not? Oh, it does that sometimes. It's weird. One of these days, I'm going to work out what I actually press to do that. So in order to build a tree, we need a root node. Which is done like this, apparently. Job tree. And then we return the tree. Happy days. So that should get us one step closer to doing something useful with a bit of luck. Yeah, when these things fail, it's like, I wanted to show me the diff. Yeah, I probably need to update my little macro thingy because this error is coming from a macro. I mean, if there's any differences in the tree, I wanted to show a diff of what's different because this tree is quite large, so it's hard to spot what the problem is. So it says it expected all this stuff, starting with job tree, and what it actually got was this remaining bit of content, which starts with job tree, but then it didn't have the rest of it, which is fine. So I suppose prior to this method being called, there's going to be some processing done, which is the whole point of this job building thing, which is going to give us a list of components or parts. Placements, sorry. These, it's going to give us a list of these, and these are somehow going to relate back to these positions, these things. I don't know how we're going to do this yet. I'm wondering whether we do need a tree or not, you see, because what operations can we do on the job? So some of the things that we said we want to do, because this job thing is sort of like it's essentially the state. Maybe it should be called job state, and you dump the job state. That's an interesting thought. Things you need to do mid-job is where my brain is currently sort of living right now. This is what I'm thinking about. So job doesn't really care about the feeder. It just needs to know which feeder it came from. So somehow there's going to be a relationship between a part and a feeder. Which will be probably defined as something on the part, or a job item or something like this. Job items. Does it have a, or do we want a tree? Quite a few different ways we could go here. See, what I'm thinking about is this. Where is it? Yeah, things you need to do mid-job. Let's expand this list again with something that's in my brain at the moment. Add. Or it's sort of like so if you've got a panel, you basically decided you don't want to place X amount of the variance on that panel anymore. Change design variant skip add slash remove X out. Right. So say you're running the job and you've got to make a panel with 10 of these things on it, but then halfway through the job you realize there's some problem with one of the components or whatever, and you don't want to build any more, and you're not taking all of the parts off the ones that you've already placed, right? So you want to say, okay, we'll continue placing this, because you might have only noticed it like halfway through building or placing one variant, right? But you don't want to once this one's finished, you don't want to do any more. So you'd pause the job, you'd go back to the job tree or whatever job definition, and you would say this panel, no, 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 don't, skip these ones, and then you would want to say, okay, job resume. And it might be easier if all of the placements for a job were in a node in a tree, and you could put the skip flag on the tree node itself. Interesting. I'm just thinking about how sort of the 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 sort of like the planner for all this stuff. Like, how would it it goes from one component to the next component, but what would it do at the end of a placement? Would it just go back to the next node in the tree and the thing? I don't know. Because the other way of doing it is having just like a standard list of things, right? And in that list, you might have, it's an optional panel, and then, yeah, I don't know. I don't think that would work as well. I think the job probably needs to have a tree. Making a tree probably makes sense for the processing of the job, handling of the job once you've created it, modification of it in future, and so on. I think it probably lends itself fairly well to this, rather than just a list of placements, essentially. Hmm. So, how does this relate to what we're trying to do at the moment? We're trying to print out a job tree. Um, and we need some source or data structures. So if a source data structure is a job graph, as in a tree, and then we print out a tree, a particular type of tree, from this job graph, that might work. But all the nodes on this graph thing need to be ordered. I think what I'm going to need to do is do a little bit of research into sort of like Rust, sort of B trees and graphing things and all this kind of stuff before I continue any further with this. Because I can see this, yeah. Let's just search for graph. Yeah. There's lots of all this, there's lots of, yeah. Graph algorithms. Directed graphs, rayon, yeah, this, what was this? Yeah. Yeah. Not that. Yeah. This kind of stuff. Yeah, so I need to do a bit of research on this, I think, before I get any further, go any further with this. So I think that is going to do it for this stream, because we're sort of blocked by my lack of knowledge or lack of I haven't got any decisions made yet. So I need to do a bit of research and make some decisions, which isn't very exciting stream content. So we'll leave that for now. But what I want to document in these streams is some of the thought process behind what it is that we want to create. Not necessarily how that we create some of it, yes, but documenting the sort of thought process of what we're trying to build is key. And this is sort of like more of a how we're going to build it kind of thing, which is more of the detail. The detail is still nonetheless important. But choosing like dependencies and all this kind of thing, it's like doing research is not sort of fantastic stream content. So yeah, so we'll leave that there for today and we'll come back to it. And hopefully on the next stream, we might be a little bit further on the way to progressing, creating a graph from which we can build a tree from, and start creating some of the data structures in memory and so on, and try doing it. I might have a little experiment of just creating it and trying that with a couple of the different libraries that are out there for this kind of stuff, and then just pick one that I like, and then on the next stream continue with using it. I think that's probably the way to go. All right, so we'll leave it there. So just remember, it's only software. How hard can it be? We'll find out in the next one. See you guys later.